So what do we get if we calculate this? Well, again, we need to get an antiderivative for cosine of x minus sine of x. That'll be our first job, and then we can plug in our endpoints and subtract afterwards. So let's start with an antiderivative. So an antiderivative for cosine of x will just be sine of x. So we've got sine of x, and then an antiderivative for negative sine of x is going to be cosine of x, because if you differentiate cosine, you get minus sine of x. So that one, this will be our antiderivative, sine of x plus cosine of x, and then we're going to plug in the bounds pi over 4 and 0. So let's do that. So plug in pi over 4, and you get sine of pi over 4 plus cosine of pi over 4. And then all of that, that's what you get if you plug in pi over 4. Now if you plug in 0, just be careful with brackets, you'll have minus sine of 0 plus cosine of 0. And what this actually works out to be, let's look at what you have here. Sine of pi over 4, this is equal to root 2 over 2. And also, cosine of pi over 4 is also equal to root 2 over 2. Right? Use the trig table, use your special triangles, somehow get those values. But root 2 over 2 is what you're going to get for both of those. And then, well, sine of 0 is just 0. Cos of 0 is equal to 1. So actually, if you put all that together, you have root 2 over 2 plus root 2 over 2. So you got half of a root 2 here and another half of a root 2 here. You really, if you add those together, you're going to get the square root of 2. And then here you have minus 0 plus 1. So you've got square root of 2 minus 1. That's what this works out to be. So root 2 minus 1. So that's what we get for A1. And for those of you that would insist that we could just double this value to get the area of both regions together, hold that thought. Let's just calculate A2 directly, and then we'll see. And if they're equal, well, then you were right. But if they weren't equal, we'll be glad that we calculated it separately. And either way, then you'll know for sure if the two areas are equal. So let's calculate A2. Okay, so what happens if we calculate A2? So again, we need to figure out our upper function and our lower function. And this is a good time to mention the fact that notice what's happening here with this example, why it's so nice that we start out by finding the intersection point between the two curves and actually breaking these up into two separate areas. Because if we tried to calculate this all in one go, well, there's no clear upper function for the entire region and a lower function for the entire region, because for this region, cosine is on top and sine of x is on the bottom. But then for A2, the second region, is reversed. Sine of x is on the top and cosine of x is on the bottom. So they traded places. So we can't just catch this area all in one swoop. You have to break it up into two separate areas. So that's what we're doing now. So for A2, our upper function is actually sine of x. So we're going to have the definite integral of sine of x minus cosine of x, because cosine of x is the bottom function. So then our bounds now for this one, when we're calculating A2, our left endpoint is going to be pi over 4, and our right endpoint is going to be pi over 2. So we're going to go from pi over 4 to pi over 2, like that. Okay, and that's what we'll calculate. So do the usual. Start by finding an antiderivative for sine of x minus cosine of x. So an antiderivative for sine of x, do it term by term. Antiderivative for sine of x will be negative cosine of x, because if you differentiate cosine, you get negative sine. So if we differentiate negative cosine of x, then we'll get positive sine of x. So that's an antiderivative for the sine of x. Now for the cosine of x, an antiderivative of cosine of x is just sine of x, and we've got subtraction in between. So we'll go minus sine of x. So that is our antiderivative. Now let's plug in the bounds, pi over 2 and pi over 4. Oops. Okay, so that's what we'll plug in, and we'll get our value. So plug in pi over 2 first. We'll have negative cosine of pi over 2 minus sine of pi over 2. And then we're going to go minus negative cosine of pi over 4 minus sine of pi over 4. So that's what we get if we plug in our endpoints. Now it's just a matter of carefully working each piece out. Because cosine of pi over 2, well, that's 0. We've got the graph of cosine right here. It's equal to 0. So this is going to be equal to 0. Sine of pi over 2, well, that's where sine hits its peak of positive 1. So this is equal to 1. Cosine of pi over 4 and sine of pi over 4, that's just like we had up here. Those are both equal to the square root of 2 divided by 2. So this is equal to root 2 over 2, and so is this one. So what do we have here? There's a lot of sign changes and negative signs here, so let's just take one extra step to do this carefully here. So we've got negative 0, well that's just 0, minus 1, so we've got negative 1, and then minus, and this bracket here is that bracket there. So we've got negative root 2 over 2, so minus root 2 over 2, and then over here we've got minus root 2 over 2 again. So what you really have here is minus 1. If I distribute that negative into the brackets, it's going to cancel with both of those negatives. So we'll have minus 1 plus root 2 over 2 plus root 2 over 2. And guess, well, that root 2 over 2 plus root 2 over 2, this is half of a root 2 plus another half of a root 2. These two combined are just exactly root 2. Then you got your minus 1 over here. So it actually is going to be exactly the same. It is actually going to be equal to root 2 minus 1. Okay, so that finishes our calculation for the second area. So now we can add those two results together and finish the problem. So therefore, let's say this area, but just write A for area, is equal to A1 plus A2. And if I add those together, I've got A1 was root 2 minus 1 and A2 was root 2 minus 1. Then it really is just doubling root 2 minus 1. So we're going to get 2 times root 2 minus 1, and that is our final area calculation. Okay, and that is how we can finish that problem.